In this video, we express derivative as a function, and let me remind you of the concept of instantaneous rate of change from last time. Last time we talked about instantaneous rate of change. For example, if we want to find the slope of the tangent line of the function, the curve of the function f of x, at a specific point, let's call this point x here. So we want to find the slope of the tangent line. The tangent line looks like this. So this is the tangent line at the point x. It touches the curve of the function f of x at the point x. Okay, and here we may choose another point that's very close to x. Let's choose x plus h. This is another point, and we can use the average rate of change to find the slope, to approximate the slope. But as we described last time, instantaneous rate of change gives us the rate of change at a specific time. So when h is very small, when h is positive and very small, then this point x plus h will be very close to the point x. So it might be here or even closer. And then we get a better approximation. So in that case, the instantaneous rate of change is given by f of x plus h minus f of x over h, where h is very small. Now, if we use limit notation, we write limit as h approaches 0. That means h is very small. We get instantaneous rate of change at a specific value, at specific time, or a specific value. And that's what we call the derivative. And for the derivative, we use the notation f prime of x, f prime of x, or f dash of x, or the first derivative of f of x. This is read f prime of x, or the first derivative of the function f of x. And this is a function actually because we have the variable x here. Even if we compute this and we get f prime of x equals 5, for example, constant, it's still a function. So after finding the limit, the derivative, the limit, we may get, for example, 5x plus 1. This is a function. This function is called the derivative of the function. Now, keeping this in mind and remembering that geometrically, the derivative, this formula here, the derivative is the slope of the tangent line, slope of this line, slope of the tangent line at specific point. We can use specific point to find the slope of the tangent line. So the slope of the tangent line is the interpretation of the derivative. So keep this in mind and let's do some examples. Let's try to find the derivative of the function f of x equals 2x plus 1. Now, for now, we only have this definition. We don't know anything about rules, and later we will learn some rules so that we don't need to use this limit and compute it as we learned before. When we learn some rules, we can apply them right away, and we don't need to spend that time on finding limit that includes simplifying, using some algebraic manipulations to find the limit. So for now, we have this formula. This formula is called the definition of the limit of the first derivative. First derivative. Now, we have this example 1. We are given a function f of x equals 2x plus 1, and we want to find f prime of x, or derivative of the function f, using the above definition of the limit. So let's apply this formula. In order to apply this formula, we need to find f of x plus h, and then subtract f of x, the given function, and then divide by h, and taking the limit as h goes to 0. So let's find f of x plus h. To find f of x plus h, we need to plug x plus h here into this function. So when we plug this here, we get 2 times x plus h plus 1, as you can see. And then we simplify, we multiply 2 by x and then 2 by h and then plus 1. So this expression will come here for f of x plus h. So let's apply the derivative formula. So we have limit of f of x plus h, that is 2x plus 2h plus 1, minus f of x. F of x is here. What is f of x? F of x is the original function. It's 2x plus 1, and it's better to use parentheses here so that we don't miss the negative sign. The negative sign comes with 2x and with 1. It's for both of them. And then we divide by h, and h approaches 0. Now we have a limit problem. We can simplify the numerator. We have 2x plus 2h plus 1. Now we insert the negative sign on the parentheses here. We get negative 2x minus 1 over h. h goes to 0. Can we simplify more? Okay, we can simplify. 1 minus 1 is 0. 2x and minus 2x is 0. So this expression becomes, this limit becomes limit of 2h over h as h approaches 0. But as you can see, we can cancel h from the numerator and denominator, and we get 2. So the derivative of the function f of x is equal to 2. It's a constant function. So this is the derivative of the given function. Now let's find the derivative of the function f of x equals x squared plus minus 1 using the above definition. So for the definition, we need to find first f of x plus h, and that means you plug x plus h here. So this gives x plus h squared minus 1. And then you need to remember the how to expand this expression. So if you have a plus b squared, this is a squared plus 2ab plus b squared. And if the sign is negative here, this sign is negative. And the other sign for b squared, it's still positive. So you need to remember this. Now we apply it here. So x squared, square root of the first, plus 2 times the first times the second. You can write it either 2xh or 2hx. I prefer to write it 2hx, but that will not change the result. 2hx, and then plus h squared, the second term squared, minus 1. So this is f of x plus h. Now we apply the formula. F prime of x is limit as h approaches 0 of f of x plus h, and that is x squared plus 2hx plus h squared minus 1, minus f of x, because here I'm reading from this formula. Now minus f of x. F of x is the original function here. It's x squared minus 1, and again I use parentheses here because I have 2 terms and negative sign, so I don't want to miss any sign. And then I divide by h. Let's insert the negative sign here. I get x squared plus 2hx plus h squared minus 1 minus x squared plus 1 all over h. h goes to 0. And then we simplify this expression. We have x squared minus x squared is 0. Negative 1 plus 1 is 0. So this is limit 2hx plus h squared over h. h goes to 0. And as you can see, we have h common here. So we have h here, and h in the denominator. So we can take h as a common factor from the numerator, and we are left with 2x plus 1h all over h. h goes to 0. And then we can simplify. As you can see, we have h in the numerator, h denominator. And after canceling this, we just plug h equals 0 here. So we have limit 2x plus h. h goes to 0, and when we plug h equals 0 here, we get 2x. So the derivative f prime of x, the derivative of the function f the function x squared minus 1 is 2x. This is called the derivative of the function, and this gives us the slope of the tangent line at any point. For example, if you want to find the slope of the tangent line at, for example, x equals 1, the slope is positive 2. For example, here we have the function f of x equals x squared minus 1. Let's graph this function. The graph looks like this. This is x squared minus 1. And then if you want to find the slope of the tangent line at, for example, at x equals 1, this is x equals 1. So the tangent line will look like this. This is the tangent line. What is the slope of the tangent line at x equals 1 at this point? We just plug it here. F prime at 1 is 2 times 1, which is equal to 2. So the slope at this point is 2. So this is a general formula. It's a function. We could express derivative as a function of x. And the importance of this is that I can find the derivative or the slope of the tangent line at any value x. Now let's solve another problem. We have the function f of x equals 1 over x. We want to use the definition to find the derivative. So let's find f of x plus h first. Now all what we need to do is to plug this here. So we write it instead of x, we have x plus h. So this is 1 over x plus h. Now we use the formula f prime of x equals limit of f of x plus h, that is 1 over x plus h, minus f of x is 1 over x. Let me write the definition here to remind you. So we found f of x plus h, that is f of x plus h. Then minus f of x is 1 over x, all over h goes to 0. And if we see a numerator, denominator, I mean fraction in the numerator, we need to get a common denominator. Because if you plug 0, h equals 0, you get 0 over 0. When we plug h0 here, we get 1 over x minus 1 over x over 0, but the numerator is the same. 1 over x minus 1 over x is, the two terms are the same. That means the difference is 0. We got 0 over 0. That means we didn't get a final answer. We need to simplify. How to simplify or to proceed? We need, if we have a fraction in the numerator, we need to get a common denominator. Now how to get a common denominator? Let me remind you, if you have a over b plus c over d and you want to get a common denominator, you can do the following easy method. You cross multiply these. A times d plus, if we have a plus, if it's minus, we use minus. Then we multiply this way, c times b, and divide by the product of the denominators, b times d. So keep this in mind, and if this is minus, then this is minus. Let's apply it here. 1 times x, and write it here. Limit, h goes to 0. 1 times x is x. Now the sign is negative, and then we multiply 1 by x plus h, that is x plus h. And we put it into parentheses because we have negative sign here and two terms. And then we divide by the product of the denominators. We multiply x by x plus h, and that is x times x plus h. Now we still have a denominator here. What should we do with this denominator? For this denominator, the original denominator, we make it h over 1, and then we flip it and multiply it by this expression. So when we flip it, we get 1 over h, and we use multiplication here. This division becomes multiplication. So you should remember this. Now let's simplify more. We have limit as h goes to 0. Now let's insert the negative sign here, x minus h over, now we have h times x plus h. That is, we just multiply this by this, x times h times x plus h, and then we simplify more. We have x minus x is 0, so this gives limit of negative h over xh times x plus h approaches 0, and then we simplify more. We have h in the numerator, h denominator, we can cancel them, so we have limit negative 1 over x times x plus h. That's what is left here after canceling h. H goes to 0, we just plug it here, and we get negative 1 over x times x plus 0, and that is negative 1 over x squared, because x times x is x squared. So the derivative of f of x equals 1 over x is negative 1 over x squared. So let me write it here. The derivative here is negative 1 over x squared. This is how we use the definition of the derivative, the first derivative, to find that derivative. Now the last example here, what if the function is constant, f of x equals c? For example, f of x equals 5. What is the derivative? Let's see. We have f of x plus h. What is f of x plus h? We need to plug x plus h, but we don't have x here. So that means we still have c, because this is a constant function. If you choose any value for x, the right hand side will not be changed. If you plug 1, you don't have x on the right hand side to substitute it. So it always gives c. I mean, for example, f of x equals 5. That's a constant function that looks like this. It's the blue function, f of x equals 5, the blue horizontal line. For example, if you want to find f of 2, the image is 5, the height is 5. If you plug, for example, 3, you still have height 5. If you plug negative 1, you still have 5. That's a constant function, gives constant value. So if you substitute x plus h, for example, if it's here, you still have 5 as an image. So f of x plus h is c. Now we apply the formula. F prime of x equals limit of f of x plus h, that is c, minus f of x. F of x is the original function, it's c as well, over h. H approaches 0, but c minus c is 0 because it's the same number. So 0 over any number is 0. 0 over h, and limit h goes to 0, that is 0. So since the numerator is 0, the answer is 0. And here we don't plug 0 because this is h approaches 0, but it's not equal to 0. So from here, you can just write limit is equal to 0 since the numerator is 0. So that's correct for any constant function. For example, if the function is f of x equals 5, then the derivative is 0. And that's the first rule that we need to learn in order to skip all these details, in order to avoid using that limit and the definition of the derivative. We can use the rules, and the first rule says if you have a constant function, then the derivative is 0. For example, here, if you plug 5, 5 minus 5 is 0.